Hear that microphone, huh? I bet y'all hear that microphone already. I could have been talking shit. Y'all would have heard me. Let me see. Get that damn camera going. Microphone check. 1, 2. Desktop audio. Where's the webcam at? There you go. You are now tuned into the network. Bruh. With a lag. The YouTube channel that takes complex networking topics, dumbs it down to a more simple language. Hashtag lab every day. We are going to be working on the campus lab that we was working on in Packet Tracer. Y'all know my boss created this lab. It started out as with a conversation with me and him. Actually, I think it might have been during my my review, and I was talking about how I want to do more layer 3 stuff. I'm like, man, I'm tired of being in these network closets, man. I wanted to start doing some more, data center stuff. And he's like, oh, okay. And I told him I've been doing some more labbing and stuff. So he said, oh, you want to do some more layer 3 stuff? I'm gonna do a lab for you. So he gave me a static route lab, the one that y'all seen a couple streams back that we did together. Hopefully y'all downloaded it and did it with me, and I'm not the only one that's over here doing it by myself. I'm hoping y'all do this with me, and that's the point of these live streams and stuff. We got my man Pete in the building. A weather report in the bottom right. Rain coming. And yeah, over here in sunny Florida, it was it pouring? I mean, we got some thunderstorm. My daughter, she got startled, and then we ended up going to the park. The park was really wet, but it didn't rain over my side of town. So we drove over to the park. It was wet, but it didn't rain over here. But you're in sunny Florida? I thought you was I don't know why I thought you was in Australia or something like that, man. You lying, man. This man, you killing me, man. You ain't in no South Florida, Pete. I know you somewhere in Australia or something like that. I can't remember, man. Killing me, man. We got Dave W in the building. We got Anders Tech in the building. And I appreciate you guys for tuning in, man. I gave you a bro. So I hope you guys are downloading this. I hope you guys downloaded this. You talking about here in sunny Florida? I know you're not in Florida, man. You said good morning early in the chat over there. Let me copy the Discord server. You guys don't know, we're going to be working on this lab here. Where's the damn Discord server? It's over here. That's why I was mentioning this guy. I'll give you a second here. Anybody that's new to this channel, if you want to follow along with us, you're going to have to join the Discord server. Invite people. Copy. And then click that link that's going to be at the top of this. That's going to be at the top of this chat right here. And I was asking what time is it over there too. I was over what time is it over there? You ain't even know damn Florida, man. Let's see. Join here. I see. I gotta get prepared, y'all. We gonna read one current event, give it some time for some people to tune in. But if they would have known about the network, they would have known about it, and we'll just jump right into it right after this. Okay, so that is the Discord server. Pin this message. Join that, and then you can download this lab and follow it along with us. The one that you see in the background over there. I know it looks like a whole damn. Don't be alarmed. Don't be intimidated by it. We started this from scratch, so you might have to go a couple episodes back to really follow along. We kind of halfway through it right now. So we already did Orlando lab. We did the Tampa network. My boss added the Daytona network. As you can see, that's what we're gonna stream. Or that's what we're gonna end up configuring on this side right here. He gave us some tasks. Again, the tasks are in the Discord server. So we have a couple minutes for some people to tune in. In today's news, some top 100 100,000 websites collect everything you type before you hit submit. I mean, I heard about what do they call them? Like cookies and not the actual cookies you eat. For anybody that's trying to give me the little, so you got to be quick with that. This is what I was trying to give y'all. Not the actual cookies you eat, but the actual thing that logs tracks your website, your browsing history. But I heard about those. I heard about what else other than cookies. Keyloggers, which is what they explained in this lab here. I mean, in this this article here, they say a number of websites include keyloggers, which I didn't think websites actually did it, but damn, that don't mean they can get your password. Well, they would have had your password anyway. But a number of websites include keyloggers that covertly snag your keyboard inputs. keyboard inputs. When you sign up for a newsletter, make a hotel reservation, or check out online, you probably take for granted that if you mistype your email address 3 times or change your mind and X out of the page, it doesn't matter. Nothing actually happens until you hit the submit button, right? Well, maybe not. As with so many assumptions about the web, this isn't always the case. According to new research, a surprising number of websites are collecting some or all of your data as they type it into a digital form. And then sometimes on top of that, they take your information and sell it off to other advertisers and other websites, right? Lately, I've been seeing a lot of ads for goddamn them uplift desks. Y'all know, because I'm looking for a desk. The ones that are adjustable and stuff like that, because I'm gonna be moving pretty soon. I'm gonna have an office, right? So I'm looking for a desk, and all of a sudden I've been seeing these banners and ads saying, "Hey, look, uplift desk. They got these for $17.99. They got these for So they track your history like that, right? Researchers from KU Leuven, Radboud University, and University of Lausanne, never heard of any of these goddamn schools, crawled and analyzed. That web crawlers is another one. Crawled and analyzed the top 100,000 websites, looking at scenarios in which a user is visiting a website in the European Union. That's why I never heard of them schools. And visiting a site from the United States. They found that 1844 websites gathered an EU's user email address without their consent, and a staggering 2950 logged the user's email in some form. Many of the sites seemingly do not intend to conduct the data logging, but incorporate third-party marketing, just like I told y'all. They take the information and sell it off to these other advertising companies, which is probably what's going on with these adjustable desks that I've been looking at lately, and analytic services that cause the behavior. So, I mean, like I said, I kind of knew about pretty much web crawlers, cookies, and goddamn, web crawlers, key loggers too, but I didn't think they actually have key loggers to actually monitor your every keystroke. That's just for websites to do that. I would think, man, they kind of infringing on your privacy and stuff like that, man. So, anyways, Pete is 10. Oh, it's 10 in the morning over there. That's what's up. Also, redistribution is new for me. Well, yesterday we did a redistribution lab, so you might want to go back one episode. I needed a refresher. Truth be told, my boss gave me this lab on Friday. He was like, because I kind of trolled him. I was like, oh, man, you gave me that static router lab, that floater lab. And when I emailed it back, I was like, oh, that shit was easy, man. He's like, okay, bet. Damn, I ain't got no sound effect for that, man. I ain't got one for that. Anyway, he just was like, okay.
It's so hard to click.
I ain't got one for that. But anyways, he was like, oh, okay, that was easy for you? Okay, bet. Give me a till the end of the day. I was like, okay. Well, as y'all can see right here, I've created a monster. So if I zoom out right here, y'all see how this lab looking like so far, right? That's just the beginning. He actually gave, and what we're going to do today, we're not even going to do all of the stuff that he added. I just said, you know what? I can't do all this in one stream. Let me get it all configured first, and then try to, learn it, and then so that way I can explain it to y'all. But when I saw it, I was like, oh, this is going to require some route redistribution. I'm going to need some refreshers on that. So that's why was it yesterday's lab? No, Friday, when I did the Friday live stream, we did a both on NetSim lab on redistribution. I needed a refresher on that, and that's what we're going to do some of it. I think we're going to do some of it today. Anders Tech said built-in loggers on key loggers and websites. Yeah, I didn't think so. I mean, I know there's, like applications that you can, or executables that can use to do key logging, but actual websites doing that too, like public websites with HTTPS enabled. That's crazy, man. Some sites can read your clipboard. That's crazy. Shout out to Kobe and Eli for that. Fun fact there, but that's crazy, man. But anyways, let's go ahead and get started. As y'all can see, we already configured Orlando. We did the wide area network over here. And then we did Tampa. Let's go ahead. My boss said we got to go ahead and do Daytona. And today, so this lab, that's why I titled it Mutual Route Redistribution, Eigrp, and Spanning Tree, because that's what he asked for in his lab, right? We're not going to do, and there's, like I said, there was way more that he added, but I said we're not going to do all of that. So as y'all can see, just by the looks of this, right? He got, this router is in BGP ASN 100 and also in Eigrp 100, right? So that means, if y'all know anything about route redistribution, that means it pretty much, and this is how I explain it, it's a router that can speak 2 different languages, and he gonna be in between one person that speak one routing protocol or language, and the other side gonna be speaking another protocol or language, and he just sitting in the middle. He just the middleman, and just kind of like translating the information. And that's what this guy is going to be doing. This guy right over here. This guy right over here, right? So we got this side. We already know that from the past couple streams we configured static routing, but he's also now he's going to be participating in Eigp along with this guy who's participating in Eigp, and then we got over here it says Eigp 100, and I believe these three guys right over here. Well, I forgot these three guys right over here. Just them guys right there. They're going to be participating in Eigp. So, again, he is going to be distributing. And Pete, that's what redistribution is. It's pretty much a translator for two different routing protocols or languages. So, because remember, they're not really languages. They're actually routing protocols. He's just the router that's sitting in between the two, also known as an ASBR or Autonomous System Boundary Router. And he'll be transferring, or he'll be translating, in this case, BGP. Oh, you speak BGP? Okay, well, this guy don't. Let me translate whatever you want to say to him to this guy who speaks Eigrp, and that's what redistribution is. All right, so let's go ahead and get started. I'm over here talking y'all head off. Y'all know I like to try to give the explanation first before we actually do the configuring. So part one, task one, he says configure BGP between routers 5 and 7 towards Daytona. Well, we know Daytona is right there on the right, on the bottom right. Let me zoom in a little bit on where we're gonna be working at. Let's he said between 5 and 7, which is right in here. So let's zoom right in there, right? Bloop, so y'all can see, and I'm not in the way, right? Let me do it a little bit more. Bloop. Zoom, scroll down some, and it's gonna be right over here, right? So he said configure. Let me move this out of the way over here. All these cables and shit, man. I'm gonna try to get me a new microphone too, because I play these back, and I've been hearing feedback and buzzing sounds. I don't know how y'all not complaining or not hearing any of that, but I try to listen to it in my car, and it's like crazy. But anyways, 5 and 7, he said they need to be participating in BGP, right? Configure it between the two. Use ASNs listed in the topology. What ASNs we got here? Because initially he said use any ASN. I don't know if that was a trick or not, but really, this guy says he's going to be participating in BGP 200, and this guy's going to be participating in BGP 100. If you know anything about Packet Tracer does not support internal BGP. So that's probably why he made them two different ASNs, right? Does anybody know the difference between internal BGP and external BGP? BGP, or IBGP? What's the difference between the two? I'm going to configure this interface while y'all get that. Go to config mode, right? That interface is, what's that network? 110.10.1. 110.10.1.1, right? What interface is that there? I think it's this one right here. Gig 001, right? AO, yes indeed. Appreciate you for tuning in, AO. I ain't see you in a minute. Interface gig 0/0/1. I believe that is the interface we got to configure, right? If it's up, yeah, it's up down. No, it should have been down. Let me see. Yeah, because it's not no serial interface, so that's the only other one. That's it right there, right? This interface is what I need to configure, right? Yeah, because them two already used up. So let me configure the gig 00 interface, and then that IP address *. Pete said the internal is not between autonomous systems. That's correct. Yeah. So two routers, if they sit in the same ASN, that's internal BGP. So we got a router that's in, I don't know, ASN 5000, and another router that's also in ASN 5000 that's internal BGP. Packet Tracer does not support that feature, so that's probably why he made these two routers sit. These two routers right here, as you see, that one's in ASN 200, that one's in ASN 100. So that's probably why he did that. Because I remember him texting me, was like, "Damn, man, Packet Tracer don't support it." I'm like, "Damn, what he got cooking over there for me, man? He trying to cook something up over there." And he's like, "Damn, he trying to stump me and shit." So this address supposed to be 100.10.10.1, and then that guy's .2. So 100.10.10.1 subnet mask of /30. That's what 255.255.252. All right, we're gonna no shut that bad boy. He's already up down. So let's go ahead and configure this guy right over here, which it should be. What interface should that be? Let's see. I'm trying to do it without hovering the mouse over it, just to kind of challenge myself, right? Go to enable mode. As you can see, right now it just says router. We need to change his host name to what? Router 7 host name. router 7. For anybody that's new in here, now y'all know how to configure a host name. Show IP, do show IP interface brief, and that's not going to tell me what it is. It's probably going to be 00 though. So let's go ahead and no shut that just so we can see. I'm just trying to see which one is the interface that's facing, right? Which one is the interface that's facing router 5. And unless I hover my mouse over it, there's no way to really tell, and I ain't trying to do that. So I'll say it's interface FA0/0. Let's turn that up and see if that's it, right? No shut. As you can see, it's green, so that was the interface. Now let's give them the IP address of 100.110.2, right? So IP address is 100.10.10.2. Anybody got any questions so far or anything? Or 255? Did Pete answer this? Did Pete's answer anybody's question about internal BGP versus external BGP? 252 is the subnet mask, right? Let's just see now if router 5 can ping router 7, right? Which is 100.2, right? So we already see now the interface came up. So most likely he'd be able to ping his directly connected neighbor, right? Matter of fact, let's just see if he got a route to it. Show IP route, and then let's do connected. Didn't know you could do that, huh? So he obviously got a route to that network, and he should be able to ping 100.10.10.1. And we got a reply, right? So that's a good sign. That's one thing I also learned, man. That y'all know how I'm always like verify. I'm always talking about how even if it's something simple like this. I know it's a directly connected neighbor, but don't feel bad that you got to ping it just to be sure. You know what I mean? I know it's packet tracer, but we got to make sure that we can ping it at least. What's the next thing we got to do here? So we configure. Oh, now he says configure BGP. So we did the IP addressing. Let's go ahead and configure BGP. Use the ASNs listed in the topology. This guy's participating in BGP 200. That one's participating in BGP 100. So let's go ahead and do that. Let's go to global config mode. How do we do that? It's router BGP. He said 100, right? No, this guy's in 200. See, check that out first. BGP 200. And then we're going to do, what network should it be in? It should be the network that catches this interface right here, right? The directly connected one. We're going to put that into BGP, that interface. So network that, right? Should we put the, I believe you got to do network mask, right? Or is it mask? Yes, you got to do the network mask, which in this case is /30, right? 255.255.255.252, right? And then we also got to define who our neighbor is going to be. So in this case, NIE neighbor. Who's the neighbor? Who's router 5's neighbor? Is BGP, router 7. Router 7 is his neighbor. How do we make him a neighbor? We just put the actual interface that's over there. So in this case, it's 110.10.1. So 100.10.10.1. And then the remote AS. What's the AS the remote device is in? So in this case, the remote AS, or you could say neighbor AS. I don't know why I ain't call it that, because that's his neighbor essentially. He sits in BGP 100. So what's the remote AS? 100. We press the question mark for context sensitive help. You see the CR there. That means carriage return. That means ain't nothing else to type right there or there. So, right? So we press enter. Can I configure the local system as neighbor? What the hell am I doing? That's not. I put 100. So you know I did wrong. Hold on, let me see something. What did I do here? Oh, I'm glad I see this right there. I made a mistake for sure. Cannot configure the local system as neighbor. So what did I do? You know what I did? The IP address is wrong there. I'm supposed to be .2.
You stupid.
I had to be quicker than that. So I made myself as a neighbor in that case. So that's wrong. What we meant to do is .2. For anybody that's watching that don't know what happened there. I said this is my BGP neighbor. He sits in ASN 100. That was correct, but I put that his IP address is 110.10.1, but that's me. What the hell?
Are you fucking stupid?
So I meant to put .2, press enter, and as you can see, nothing happened there, but we could at least see show IP BGP summary, and we'll see that we've got at least the neighbor that we pointed out to, which was, where is he at? Right there. But BGP is not quite up just yet. Even though it says up, that it's configured on this router and it's up, we don't typically, I want to say there is another option right here to tell you whether it's idle, active, or what are the other states? I can't remember. Matter of fact, let me pull up the cheat sheets. Yes, there's also a cheat sheet to BGP from courtesy of packetlife.net. Shout out to Jeremy Stretch for that one. Y'all know I'm always promoting this website. Like I said, that's been out for years and stuff like that. So great website. These are the states for BGP right here. The neighbor states: idle, active, connect, open send, open confirm, and established. And if we see that it is established, obviously, and we're a neighbor, it is established, and that's what we're looking for there. In this case, I don't remember what, there was supposed to be one more that would tell you whether it's active, what the states are right there. I don't know if that's just a packet tracer that's limiting that feature, or am I missing something? I don't know. Y'all let me know. So we configure BGP on there. Let's go ahead and do the same thing on this side and make him define his neighbor, and then we should see BGP come up. Go to global config mode, same thing, right? Router BGP, but he is in ASN. This guy's in ASN 100, right? So 100 right here. We'll put the network address, which is 100.10.10.0 network mask of /30.255.252. Press enter, and then we'll define our neighbor in this case. In this case, our neighbor is 100.10.10. Now I can put .1. And then put the mask right there, and then I mean not the mask, remote AS. What's the remote AS? In this case, the remote AS is 200, right? I'm in, this guy right in here in 100, that guy's in 200, the other guy's in, I said it, 200, right? 200. Press enter. Now we can see we already got a message that says BGP is up. Let's go on the other side and see if he's got that message as well. Yes, he does. See that syslog message? It says the neighbor is up now, right? We got a couple commands we can look at. Packetlife.net. I'm trying to tell y'all, download these. Here's a couple troubleshooting commands we can learn. We can use. I already ran the show IP BGP summary. You seen how that output looked like. Let's see who my neighbor is with that command right there. Matter of fact, I'll copy and paste it. He said, okay, y'all kind of quiet over there. Just y'all just paying attention. That's good. That's good. I hope this helps y'all out. But what's the other command I wanted to use? Yeah, show IP BGP neighbors. Paste, press enter. You can see wealth of information. I'm not gonna go over it, but if y'all running this lab, run it as well. You can see a whole bunch of stuff in here. Which BGP neighbor, which BGP version we're running. I think there's a routing table version also on here. But we see the remote router this is from this guy's vantage point. This guy over here. That's his vantage point I ran that command from. His neighbor was .2, right? See that? Come on, man. All many goddamn windows. That's his neighbor ID. How long it's been up for? 42 seconds, right? Last read, 42 seconds. Last write. We got the whole time. Like I said, a whole bunch of information. I'm not gonna go over all of it. Sent and received. Opens, right? What is open? Open sent right there. Open confirm. Remember, these are the neighbor states right here. If you want to go further in depth, just like Google BGP's neighbor states. But this again, these are quick little cheat sheets on what the states are. What else we got here? The table version. When the BGP table gets updated, we'll see a different version number. Just a whole bunch of stuff, man. Again, I'm not gonna go over all of it, but that's a good command to look into. There's also show IP, as you can see right there, show IP route BGP, and see what routes we know, but there's none yet. He didn't learn anything. Why? Because the only route he got was his neighbor, his BGP neighbor, but it's a connected route. It's directly connected. Once he learns a route via BGP, which this guy will eventually be advertising, then he'll start seeing BGP routes. But for now, we look at his route table, all the other routes that we did from the last couple streams, all them static routes that we created up here. Remember from the last couple streams, we got these directly connected routes. That's the ones that are right over here. It's physical cable. Remember, connected and local. Connected is for the physical cable. Local is pretty much the interface, right? The .1 that I made a mistake from.
You stupid.
What was the next task? So now those guys are BGP neighbors. He also said the next task. I believe we got 7 tasks on this, right? Yep. No, I'll take that back. Mutual route redistribution. Yeah, it looks like 7 tasks here. So we configure BGP between router 5 and 7 towards Daytona. Use the ASN's listener topology. Router 5 redistribute static routes into BGP. So back to them static routes I was mentioning to y'all. He said have router 5 redistribute static routes into BGP, right? So that means we got just focus on what we was working on, right? Remember last time for these past couple streams that we did back here from Tampa and Daytona over there, right? I mean Tampa and Orlando. Back here, all this shit back here is all static routes. We did all this shit manually, right? Right over here, we got some BGP. We got pretty much a BGP being ran over here. He wants us to take all these routes that are back here and distribute them into BGP. All right, I'm gonna show you how to do that. Just like what we did in the last stream with both on NetSim. You go to global config mode, and I hope I remember this. router. We go into BGP. We're in ASN number 100. We are running BGP AS100. See, that's the remote AS. Actually, we are in 200, so I gotta be careful with that. I want to see if this command tells us what ASN we're running locally. I gotta get familiar with this command right here. I don't really run this one very often. I'm gonna need to if we're gonna be running BGP. There's a lot of shit in here, and it don't tell us. Where does it say 100? It don't tell us. So one of my favorite commands to get that information is show. You gotta get out of this and do show IP. I'm sorry, show IP protocols. You do show IP protocols, we'll see we're running BGP 200. So that would have told me right there. So we go to global config mode, router BGP 200, right? And then Kobe said, Dave said, why would the mask be /30 and not /24? Pete said point-to-point links would use /30. That is true. Pete is correct there. Now, it's the real thing is, it's ideally you want to use we could have used /24, Dave, but like Pete said, it's point-to-point link. We only know there's only 2 hosts there, so we might as well just use /30. And in /30 subnet, there's only 2 usable addresses. And Kobe also made a good point to not waste address space, because we use /24. We got how many usable addresses in there? I think 22 usable addresses. So it's just a waste of a bunch of waste of IP addresses that we're doing there. That is why. So Kobe also made a good point, and he said it matters because that private network, and it matters because that network is actually public, not private. Yes. You talking about this network over here, right? This is pretty much a public network, right? Yeah. Because remember, past this part right here where it says Tampa, that's pretty much the local network. Back here is the wire, pretty much the internet. And then this back here is pretty much still the internet. We're not getting to the local area network of Daytona, which is there in the bottom right. That's the local area network behind that switch. So yeah, good point as well. So we're in BGP 200, right? Now we're in BGP 200. The keyword for redistribute is redistribute.
Bruh.
Right? How easy is that? What are we redistributing in this case? He said redistribute static routes into BGP. That's easy. So we just do static, right? With question mark, context sensitive help for static. You see a CR there, CAS return. So we ain't got to worry about anything else. That's easy enough. So with this command right here, we did redistribute static, right? So we took all of the routes that he learned about from static and pretty much injected it into BGP. So theoretically, this guy should know about them static routes, I believe. Let me see. Let's go in here. We see BGP neighbors up, right, with that adjacency change message. We do a show IP. Let's take a show IP route, and he does not. So no, we didn't do that just yet. Let's see, what are we missing? Router 5 redistribute static routes into BGP. Let's make sure we did that correctly. We redistributed it into BGP into static. Yeah, that sounds about right to me. Maybe because you see how the routing table look like? We only see the connected and local routes. What are those? The connected route, 110.10.0, which is pretty much this route right here. And then the local route, which is the interface that he's directly connected to him. His little finger, right? That's what this is the local, the interface, and then this is the connected route, right? We did show IP route, we only see those two. But BGP is also slow. BGP is slow. Believe it or not, even though it's the main routing protocol that is on the internet and it has an administrative distance of 20, BGP is slow. It is a slow routing protocol. So hopefully I'm correct and I'm saying this correctly. And I ran that command really maybe a little too quick. Do I have a winning one for y'all? I don't. But like I said, BGP is slow.
One eternity later.
So it could be that, or we're missing something. So let's run that command one more time. So IP route. And there you go. See there? Right on time. See, now we learned about them. All these little static routes that we learned back here. All the ones we did from past streams, they're all been injected into BGP. How cool is that, right? That is pretty much how the internet works. This router needs to know about how to get to that route, right? And then that router needs to get to this network, so on and so forth. That's pretty much how the internet works. That's how you're able to see me and my big fro from all the way to Australia, Pete, because these routers take this route and be like, do I know how to get to this server? Do I know how to get to this server? He jumps into China, he jumps into Africa, and finally gets to gives this feed of the stream to Pete over there in Australia. This is why I'm so fascinated with the internet. So we took all the routes, injected it in a BGP, and that was step 2. We only got 7 steps, so we're almost done there. He said, oh, thought we were talking about the 90 Daytona network. But yeah, okay, cool. The fast forward could help. Yes, Pete, that's true. I could have done the fast forward button, but that was another thing I wanted to explain too. So Pete was talking about this right here. We can kind of like fast forward. Y'all can't fast forward me because I'm live, unless y'all go back on some of it and fast forward. But that's the cool thing about Packet Tracer. You can fast forward some and speed things up, like band tree and all this other shit, right? But that's one way to demonstrate how slow BGP is. Step 3, configure Eigrp between routers 7, 8, and 9, right? So we're 7, 8, and 9. Let me scroll up some, scroll down some. We got 7 right here, 8 right here, and 9 right here. So we got to configure Eigrp between those guys. Let's go ahead and do that. First of all, we need to turn these interfaces up. As you can see, we got a whole bunch of, we need to turn the lights on, basically. Let's configure that interface, this interface, and so on and so forth, right? Y'all just follow along. For anybody that's new, y'all could do this with me, and just... This is the simple stuff, kind of just, let me see, interface. What's going on with y'all on the weekend, man? Y'all having a good weekend? I pretty much spent it with my daughter. I told her, okay, about around 8 o'clock, I got to get to streaming. So I need you to be quiet. She watching a movie down now, right now. What interface is this? Y'all remember, I don't want to hover over it and check, so I'm going to do show IP interface. Brief, see what's down. We already know that that's BGP. That's the BGP one. 0.1 is probably going to be this side. So what I'm going to do is turn up both of them up. I'm going to do interface FA 0/1. No shut. Bloop. It's up, but it's not going to show up because the other side probably need to be up. So let's see if that was it right over there. Right. Enable. He's supposed to be router 9. Configure terminal. What I'm going to say here. Interface. What interface is that? Probably FA. Let me look at it real quick. Do show IP. They said, generally speaking, if I have a private network /24, mask is /24, and to connect private to public, I would use mask /30. Save for DMARC. Yes, exactly, Pete. I mean, Dave. Exactly. You don't have to. Again, you don't have to, but that is pretty much best practice, so that you're not wasting IP address space. Show IP interface brief. Damn, it's hot enough. I didn't mean to do IP interface brief, did I? Gig 00, give 000. I believe that's gonna be the interface. Interface gig 000. Let's do a no shut. If that turned green, then that was it. Yep. So we're gonna need to turn those, give those guys these IP addresses: 90.0.0.1 and 90.0.0.2. His IP address 90.0.0.1. Subnet mask of, I believe it was /30, right? Yep, /30. 255.252, right? And we already know shut it. Let's do it right, mem. Save our work. And then this guy right over here, he need to be 90.0.0.2. Let me go back and check my work, because anywhere we fuck up here, we won't even be able to reach Daytona. So show IP interface brief, verify. I know I'll be saying that to y'all, but I really learned how I really need to verify. I don't care how simple the task is. Verify it, man. There's been some times his IP address is going to be 90.0.0. He's 90.0.0.2. Subnet mask of 255.255.252, right? 252, right? 252. Come on, man.
Nope.
Let's go ahead and do a ping to .1. Do pint 90.0.0.1. Wait for it.
Bruh.
We got it. All right. So he was able to ping it, right? So basically, he was able to ping him and vice versa, which is pretty much a given. Let's go ahead and turn up these two interfaces. Y'all with me so far? Interface FA10 is the one that's facing router 8. So go to global config mode, interface FA1/0, and give him the IP address of, what's that interface? 90.110. Oh, you see it right there? 90.111, pretty much. So 90.1.1.1/30, 255.255.252, right? We do a no shut, bring that bad boy up. Let's do a write mem just to save our work, and then I'm gonna save it too. Y'all with me so far? Anybody got any questions? Any newbies in here? Let me know. There's a lot of smart people in that chat room over there. As you can see, there's a good discussion about the difference between using a /30 subnet and a /24, and why we do /34 wide area or point-to-point network. Now we go ahead and interface, turn up this interface, which is let's just turn it up. Let's just turn it up and then give it the IP address. I don't know what the danger is in that in the real world, but luckily this is fucking packet tracer. So go to global config mode, router 8 interface. I'm sorry. Let's change his host name first, right? He's router 8, and then give him the interface. I don't remember what interface that is. So let's do a show IP interface brief. Again, I could have just hovered the mouse over it and see, but I kind of like to just do that. Interface gig 000/0. Let's no shut that bad boy. If it turned green that side, yep, it did turn green. So that was the interface facing router 7. Give him the IP address of, what is that? 90.112, right? Don't give him 90.111. I almost give him 90.1. He's .2, right? So 90.1.1.2. I still didn't get that Finding Nemo sound effect. Y'all hit that like button and subscribe to your boy. And make sure you join that Discord server so y'all can follow along and download this file. Download this file and follow along. It's /30, so 252. Let's do a ping to 90.111. 90.1.1.1. Wait for it. We got a reply. So that's a good sign. So these interfaces are turned up. He said go ahead and put them in a Eigrp. Have them participate in Eigrp 100. Just these 3 routers right over here. Them 3 right over there. Don't worry, we're going to get to the local area network of Daytona. That's probably going to be in the last stream. I don't remember how much I split it up by. But again, it's a whole shitload of tasks that he gave me to do. I did them already, but I was like, I'm not going to do all of them in one stream because y'all just going to be like, man, fuck this shit. And unsubscribe or go to another YouTube channel. So I'm trying to do it in little bits, so little nuggets. Copying from another company over there. Let's go ahead and have router 7 enable Eigrp. How we do that? Router Eigrp. What he said, Eigrp 100, right? So again, 100. Now this guy. Back to Pete's question. Was it Pete? I don't remember who asked about. Thank you for all the explanation. We good. Okay, good. I appreciate y'all for that. Yeah, shout out to Pete for those explanations over there. Remember what I said about route redistribution, right? This guy, he's participating in BGP, right? But he also know about these static routes that's back here that we did in the past couple streams. He pretty much injected them into them. So he's told these guys, hey, look, I know about these static routes in a different language because they don't know. Well, they don't know about those static routes over there. And he let them know about them static routes over there. That's how this guy was eventually able to learn about it. So and how did he do that? He redistributed it. So therefore, again, he is an ASBR, or Autonomous System Boundary Router, a router that can speak pretty much 2 languages, right? Don't say that in an interview. That's just how I say it to remember it, right? Now we got router 7 over here. He's also participating in BGP. That guy's his neighbor, but now he's also participating in Eigrp. So we do a show IP protocols. We'll see that, right? Let me see real quick. Do show IP protocols. That's one of my favorite commands right there, right? So we scroll up, and there it goes right there. He says, I'm participating in Eigrp. That's Eigrp 100. I'm also participating in BGP 100. So therefore, guess what? He is also an ASBR. He can speak 2 languages. He can speak Eigrp on one side and BGP on the other side. So guess what? We're probably going to be doing You goddamn right. Redistribution also. So he might be taking these routes that he learned over there, and that's pretty much how the internet works. They take these routes and send them off to somebody else, and then so on and so forth. And that's how these pings are able to come across the internet, right? And Pete can watch me stream over here all the way in Florida while he's over there in Australia talking shit. So now we was going to configure Eigp. Where we at? We said Eigp 100. We're going to take these two interfaces and have them participate in Eigp, right? So how do we do that? We gotta have a network statement that's gonna catch this interface. Well, it's pretty much written out right there for us. Put the 90 network into Eigp. So we say network 90.0.0.0. We don't work with subnet masks. With Eigp, we work with wildcard masks, right? So in this case, right, I'll question mark and show y'all. It says right there, wildcard mask. What's wildcard mask? The subnet mask is /30. The wildcard says 0003. Oops. 0.0.0.3. Y'all hit me that like button and make sure you subscribe to your boy. .3. Right. We also need a network statement that's going to put this interface in Eigp. What's that? It's pretty much written out for us again. That's the network address. I used to think, what's the address I got to put in when I go into router config mode? The easiest way. It even says the keyword is network. Not the actual interface of the neighboring router or anything like that. I used to get confused and try to figure. It's the network address. The other interface over there you want to, or the interface that you have locally, which one, what's the network address for it? So in this case, the network address, my interface over here is 91.1.1, but the network address is 91.1.0. That's what I got to put in for the network statement. So network neg 90.1.1. Oops, 90.1.1. .1. Come on, man. I need my little Boosie sound effect again.
No, God!
This is mistyping over here. 0003. Right? And let's see what we're working with so far. Let's do a show IP protocols, and then we'll see in Eigp we are routing for these two different networks right here. So essentially, we put in this interface in Eigp and this interface in Eigp. Which one is that interface configured in? BGP, remember? We did that earlier in the stream. That side is configured, participating in BGP, right? So, and just by the look at this, you'll see we got BGP here. So most likely he's gonna be redistributing over there. I didn't get that far just yet, right? Let me see what's next step. He said, oh, we still didn't finish configuring Eigp. So these two interfaces in Eigp, we need to put that in Eigp and that interface in Eigp. So let's go ahead and put these two guys to become neighbors. Let's go to this guy. Get out of this. Go to router config mode, and it's Eigp. He's going to be participating in 100. Remember, the ASN's got to match with Eigp. The ASN's got to match. So in this case, it's 100. The network address, what's the network address? This interface is 90.0.0.2, but the network address is 90.0.0.0, right? 90.0.0.0. I need to remember this. That's what I keep forgetting. .3 is the wildcard mask. So now we already got a neighbor. See how fast Eigp came up? Eigp is probably the fastest routing protocol that there is right now. There is today, I believe. So now we just do a quick command show IP Eigrp. Guess what? There's also cheat sheets for that if you don't know. Shout out to packetlife.net, right? I keep telling y'all, man. These cheat sheets, boy. We already opened up the BGP cheat sheet. Check this one out. He also got an Eigp one. I think I showed this y'all already. We got the metric formula for it. And remember when I was telling y'all about the D, what the D stood for? Right there, dual algorithm. This is the algorithm that's used to run Eigp. All the math behind it and shit, that's what that is right there. All this information, right? We already ran some, here's our troubleshooting commands. I already just showed y'all, show Eigp neighbor, right? Did I show it to y'all? I was in the process of that. Yeah, I was. Show Eigp neighbor. Who's my neighbor? 90.0.0.1. Where is he at? Right over here. So I ran it. He's my neighbor, 90.1. If I do that same command, he'll see 90.2 is his neighbor, right? See, we already got the syslog message that let him know who's my neighbor. Show IP Eigp neighbor, and it should theoretically be 00.2. Y'all see that already? Let's go to do the same thing over here. Have that participate in Eigp, which is 91.1.2, right? So go to global config mode. We say router Eigp 100. network address. What's the network address? It's even written out to me. 90.110 90.1.1.0 000.3 is the wildcard mask. Anybody got a question? See, or you got a neighbor? See how it's faster than you would think. If Eigp is much faster, why don't they just use it on the internet, right?
Nope.
Eigp is an internal routing protocol. It is not built to handle external routes like the internet. BGP, I couldn't even give y'all a real answer for that, to be honest with y'all. I'm not gonna sit here and make pretend I know. That make you think, right? If Eigp is much faster than BGP, and it has a worse routing administrative distance. It has an administrative distance of 90. BGP is 20, but BGP is slower. If it's slower, how come it's the routing protocol that is used on the internet? If Eigp is so fast, maybe I wouldn't have to worry about. Damn, do I got it still? I probably do. Yeah. Treg Henry said scalability issue. That's what BGP sounded like. Y'all see when I tried to load up that routing table, it didn't even show up. It sounded like this. 30 seconds into me explaining all of this. All right, shut the fuck up, man. 30 minutes explaining all that. Then I did show IP route again. Then we saw those BGP routes. BGP is slower than Eigp essentially. And according to Treg, it is a scalability issue. So that I didn't realize. So that's good to know. He has a neighbor. So we pretty much, I think that was pretty much it for that step, right? These two guys are neighbors. These two guys are neighbors. BGP is more stable. That's interesting. Nah, I didn't know that either. Where we at now? Let's close that over there. Yeah, I gotta add that back in. Add that to my favorites over there. But yeah, shout out to Trey Henry for that answer. He said it's a scalability issue and it's more stable. I know that you can have pretty much full internet routing tables with BGP. But for some reason, that is the wide area network that is used. I mean, if it's in the name, right? EIGF, so it's what, enhanced interior. So that's another reason why too. It's an interior gateway routing protocol. That's what it stands for. So it's not an internet routing protocol, right? BGP is the one that we use. Next step, I believe, is could you use OSPF in this lab? We could, but that's not what my boss asked for.
Nope.
He said we're just pretty much following what he asked for in his lab, and that's pretty much what he did. I told him when I finished the static routing lab, I was like, man, put EHSRP, put this, put that, put this, put that. But then when he gave me this big ass lab, I was like, oh shit, damn, I created a monster here, man.
Bruh.
But I was glad he did that, and I'm learning a lot with this. But the next task was we configured Eigp, create mutual redistribution between Eigp and BGP on router 7. Use metrics if needed. Now this, I'm going to have a question for y'all because I don't really know about this answer either. Create mutual redistribution between Eigp and BGP, right? So remember what we did over here. We took all these static routes and injected it into BGP, right? That's called redistribution, right? So yes, it's redistribution, but it's pretty much one-way redistribution. We took all these static routes and injected it into that way, right? Now he said, we got this router who speaks BGP that way. He also speaks Eigp between these out of these interfaces. So we're going to take these BGP routes, inject them over there, and then we're going to take these Eigp routes. I believe we're going to inject them that way. That's called two-way redistribution or mutual redistribution. Hence the reason why I named the video of this. He said, Treg Henry said, the literature says that IGPs are built for speed, whereas BGP needs to be stable because we want the internet not too worried about fast convergence. That's a good one. Shout out to Treg for that one. He said, shout out to your boss. Yeah, for real, man. He really wants me to learn and stuff like that, and I told him I wanted to do some more layer 3 stuff, and then he said, okay, I got you, fam. And he pretty much built this. He took the time to actually build this, and I said, let me take the time to actually fucking learn this shit. So, yeah, I got some stuff I got to take care of in a second. So we got to pretty much got to wrap this up. I'll wrap it up then. There go to rain over there now. Configure, yeah, so configure Eigp, we did that already. We're on step 4, configure, create mutual redistribution. That's another way to call it, mutual redistribution or two-way redistribution. So let's go ahead and BGP and then redistribute the Eigp routes. So let's go to global config mode, router, BGP, what was it? BGP 100 in this router. And then we're going to redistribute Eigp. What's the AS number? 100, right? Press a question mark for the carriage return. I mean, for the context sensitive help, you see CR for carriage return, so ain't nothing else to type in here. With this command, we went into BGP, or actually, yeah, we went into BGP and took those Eigp routes and put it in there. Or I believe it's the other way around. I believe once you're in, that's why I always get confused about redistribution. Which one are you actually redistributing in this case? So I believe we got it to BGP and redistributed Eigp routes into them. Right? Is that what I did there? I took these Eigp routes and injected them that way. Let's see. Let's go over here and find out. Does he know about those Eigp routes? Enable, show IP, SIP IP route, show IP routes. And he don't know about them 90. Yeah, he does. Them 9110 networks. So that's what I did right there. See that? See, he learned those through BGP. Remember those 90 networks? This is 90.000, 9110. So pretty much this guy, who's not directly connected to that network over there, this one right over here, and this network over here, now he back here knows about them. How? Through BGP. Isn't that cool? Isn't that cool? Go in here and you see these B's right here. So now, like for example, this route right here, that's in Daytona or facing Daytona. That's how he learned about it, even though he's one hop away, right? We could even check show IP routes. I started doing this more often too, just drilling it down to just one route, 90 000, so 90.0.0, and now he got a route to it. He has a route to that network right there. How? He got two ways to get there, actually. Oh, I put 90.000. I meant to put. Yeah, that's it. That's it. But it's split into two. That's crazy. I could probably cause a route with that. I need to double check that. I hope I didn't put. I hope these are /30. I hope I put those in /30. But right over here, yeah, he does have 90/30, two known subnets. Yeah, there they go right there. 90.000 and then 9110. I was gonna say he got two ways to get there. He just got this full network address, which is divided into two subnets, pretty much. All right, so now we're gonna take these Eigp. Well, we did just that. We took those Eigp routes, distributed them into this way. Now we got to take these BGP routes that we learned over here and distribute them that way. So that way, these guys know about getting over there. Right? Y'all with me so far? See, watch. Does he know about the 110.10 network? Let's see. 110.10 network. Show IP routes. First of all, he need to reach router 9. Router. Y'all hit me that like button. And subscribe to your boy. If hostname router 9. If you're new to this channel. Show IP routes 100.10.10.0 not in the table, so he don't know about that network yet, just yet. Does he know about this network, the 90.000? We did that already. Why? Because we redistributed all these routes back here to there, but this guy don't know about this network back here because this guy need to translate them into that way. That's called two-way redistribution. See that? See that now? He said, thanks, Treg. Yep, shout out to Treg for those explanations over there. Yeah, those are some fun facts I did not really know right there. Foster said, what was the command to redistribute? It's just redistribute. Basically, you got to go into the routing protocol. I'll show you again, Diane. You go into the routing protocol. So in this case, router BGP. And then once you're in there, you just type in redistribute. And what are we redistributing? We are taking the AS100 and redistributing it into the BGP over here. So now we're going to do vice versa. Again, two-way redistribution. So let's go over here. So now we get out of this and say router Eigp 100, and we say redistribute, same thing, but this time we are redistributing the BGP routes. What are redistributing? The AS number, BGP, in this case it's ASN number 100 back here. So we're taking the ASN 100 routes and injecting them into Eigp, right? So 100 in this case, right? It's 100? Yeah, it's 100. I had to double check that. Question mark, you'll see we got to put in a metric. We could put a metric, or we don't have to, I believe. I believe we have to put it in a metric. That's what I got tricked about, or wasn't sure about. Treg, if you know the answer to this. But he does say in the notes here, we pretty much got to wrap this up in a second here, y'all. Using metrics if needed. Now, if I do just redistribute 100, we don't have to, or we could put in metric and then put it in the metrics. I don't know whether you need to or not. So you can see, obviously, we did it without. Let's see what happens. And this is the point of labbing, just experimenting, right? Now we took these BGP 100 routes, injected them into that way. Let's see if he can see. Remember, at first he didn't have a way to get there. So we run that command again. Get on our knees, pray to the network gods. Still not around the table. So we probably got to put in those metrics. Let's see. Let's put that again and do. Does anybody know? Wait, hold on. Yeah, we was there. We just did. We went to Eigp, redistribute BGP 100. So it was redistribute BGP 100, and then I believe you probably got to put in the metrics. And then the metrics, that's what I'm not sure what you really got to type. I'll just be putting the numbers in here. I'll put 10,000 for the bandwidth, I guess. And then the delay, we don't want to have a delay, I guess, in this case. 0 to 255 reliability. Let's just say it's reliable and say 255. This is the bandwidth, effective bandwidth, where 100% is loaded. We're going to say it's not really loaded. And then I believe, no, you can't put a 0 there. You got to put a 1. The number is going to be between 1 and 255, I believe. And then in this case, the common MTU is 1500 for bandwidth. MTU. Remember, that's maximum transmission unit. It's pretty much how much data you can fit through a link. I did a video on this like years ago on my channel. Just go deep in the playlist. You'll see it. 1500. Press enter. Can we see those routes now? Yeah, you can set them all to zeros. Y'all say, you seen what happened when I tried to put 0? It didn't even recognize that command. So I don't think you can set them all to 0. So correct me if I'm wrong, but I just tried one of them on 0. It didn't like it. So let's go over here, take a look at that routing table again one more time. Get on our knees, pray to the network gods. Still not in routing table, so we're missing something. He still don't know how to get to 110.10.0. Let's see. We took those routes and redistributed it into ASN 100, didn't we? I don't know. I don't even think it might not even show up just yet. Not like that. We probably got to go later on into lab. He said into Eigp, you can use all zeros. Okay. That's good to know. Well, that's what we're doing. We're redistributing BGP. In this case, right? We're redistributing. No, we're going to Eigp. That's where I always get mixed up at. In this case, we went into BGP and redistributed Eigp. So we went to BGP and took the Eigp routes and dumped them into that way, right? Yeah, that's what we did, because that's how Router 5 learned about the 90 network. So now we got to go to the Eigp and take the BGP routes and dump into there. And that's how I thought we did when we went to when we said router BGP 100 and then did those metrics. So let's do a show IP routes real quick. Obviously he gonna know about those other routes. See, so what I want to do is take this network where I'm directly connected to and advertise it. That's what I'm trying to do here. God, Just a little bit of time left, y'all. We may have to cut this short. Let me see. Before we move on, let me see. Oh, after that, we're going to have to do the damn SVIs and shit. Yeah. So we did the mutual redistribution. Use metrics if needed. Thought I did that. I should have left those SVIs for something else. For another stream. But, you know what? Let's do this. I'm going to skip that part for now. No, I want to stay with that. Hold on. I would have thought that network should have been in there. Maybe it doesn't go in there just yet. Maybe I gotta go later on into the lab to see that. Let me see. Does he know how to get to the enable? Show IP routes. What is it? 110.10.0 network. 100.10.10.0 network. That's not in the table. See there? So he don't know how to get into that network over there. And we gotta have him advertise it that way. And that's how I thought we just did right now. Let's take a look at those commands real quick. What I did so far. Do a show run. I gotta put my daughter to bed. Let's do a show run, and then let's take a look at it. What we did so far. We redistributed Eigop 100 into BGP. That was correct. And then that's what I thought we would have done right there. I thought that command would have went into Eigop and took those BGP routes and dumped them into Eigop. Dumped them into Eigop. That's what I thought that would have done. So, is router 9 in router 7 Eigop's table? Good question. Is router 9 in router 7's Eigop table? Let's see. Where's router 9 at? Router 9 is over here. You said is router 9 in router 7's Eigop table. Yeah, well, they directly connected, so of course. Good question, though. They directly connected. So it'll be 90.002, if that's what you're asking me, right? So if I go to router 7 and then just do a show IP routes to the, pretty much the 90.0.0 network. Yes, it's directly connected, so. And right there, as what I was saying, he's redistributing those routes. He's taking those routes and redistributing into BGP, right? Attached 4 connections, yep. So I would have thought that's what. Let's do show IP. Yeah, see, that's what I'm. Maybe it don't come in just yet. I don't know, but I would have thought before I move on, I want to make sure that these guys could see this network back here. And I thought when you redistribute BGP into Eigop, that they would have seen it. Maybe not just yet, but I don't know. Before I do all of that, let's see. I may have to cut this short on y'all, man, but I'm gonna skip that part for now. We're on step 5 out of 7. Step 5 was to create an SVI for both the laptop and the edge network. So we're gonna scroll down to this network. Scroll down some. He said creating the SVI for these edge facing ports, and then creating an SVI for the laptop. So pretty much a gateway for the laptop. So in this case, I'm gonna start with the gateway for the laptop. The laptop sits in the 10.30.2.1 network. 2.0 network. So obviously, best practice is tell you got to make it .1, right, for the gateway. So in this case, we're gonna enable. We're gonna configure and change the host name to Daycore, since this is Daytona. I'll call it Daycore, right? And this also change the label. Day-core. And if you're just tuned into this lab or this stream, hit me with that like button, and then hit me with that subscribe button. And then if you want to follow along, the link right there at the top of the chat, it'll take you to my Discord server. You join our Discord server, and then you could download this lab and follow along with us. You might have to, rewind or watch the stream later to do it along with us. But I'm gonna do an SVI and call it SVI and put it in VLAN 2, since that's the 2.0 network. And let's do interface VLAN 2. Let's give it the IP address of 10.30.2.1. Subnet mask of, what am I doing there?
stupid.
He needs a subnet mask. 255.255.0 in this case. Right? We create that SVI. We already know shut it is virtual, right? They come up by default. And let's see if the router can ping that SVI that's gonna be over here. Right? Let's go to the desktop real quick. Actually, let's make sure that it's configured. That's one thing you got to look at. That's one thing you got to make sure. He set the DHCP. Let's go ahead and change that IP address to 10.30. Oops, 30.2.10 is the IP address. It's subnet mask 355.355.0, and the default gateway is going to be that SVI we just created. So 1032.1, right? And now let's go to the desktop and see if we can ping that gateway or that SVI that we just created. So in this case, it's 10.30.2.1. Get on our knees, pray to the network gods.
Are you fucking stupid?
You can't ping nothing without the keyword ping. God damn it! Press enter. Get on our knees, pray to the network gods. Ain't nobody that's wrong. Why that's wrong? Because that interface we created was VLAN 2. This PC is probably in VLAN 1, which is the default VLAN. That's probably why you can't ping it. So let's take a look at where that PC is connected, right? Show IP interface. Show interface status. We'll see that the PC is probably connected to. Well, it don't even matter because, yeah, there he is right there. He's probably connected to FA03, and that's in VLAN 1. But the SVI is in VLAN 2, so we need to change that. Interface, what is that? FA03. Let's go ahead and put that port, interface FA0/3. Put that port in VLAN 2. VLAN 2. Now the SVI turned up, right? So that's a good sign. Show IP interface brief. And remember, verify, verify, verify. Exclude unsigned. We'll see now the SVI for the PC is up. Go back to laptop. See if we can ping it. Get on our knees. Pray to the network gods. Pause. You can't ping it. It got timed out. That's not a good sign. It's possible that spanning tree is blocking it though. And it's still not pinging it. Let's see. Yep. Let's verify that the VLAN 2 is even created. But I would have thought it would have created it automatically. Let's do a show VLAN brief. Oh, you know what? I see what I did wrong there. I put the wrong IP address. It's 1020.2.1. That's supposed to be 1030.2.1. You see that?
Are you fucking stupid?
We got the fat finger squad in the building. Let's go back to VLAN 2. Maybe I'm just rushing here. I gotta go get my daughter and put her to bed. And she gonna be like, damn, we got a lot of time to watch this movie here. Maybe I'm gonna go ahead and put it on another movie right now. I know I said I would. Typically I don't stream on the weekends for anybody that's new here. But I said I'm gonna try the lab every day. And we're gonna stay true to that mantra. IP address is 10.30.2.1. Subnet mask of /24.0. Right? Let's do a show IP. And I said, man, make sure you verify, right? Show IP interface brief. And there it is right there, 1032.1. Now let's go back to laptop. See if we can ping that SVI. Get on our knees, pray to the network gods. And we got a reply. That's a good sign. Dan J in the building. According to Dan, shout out to Dan for pointing that out. I didn't see that. My bad. He said SVI was .20, not 30. I didn't see that. I'm just now seeing that. But I'm glad I caught myself. Matt said I missed. It looks like you put .10.20. Yep. Shout out to Matt Carroll for that. Y'all both caught my mistake. Yeah, that's what I did. Yeah. So I put the wrong IP address. And for all y'all pointed that shit out. My bad. I'm sitting here trying to teach y'all, and I'm fucking y'all up right over here. I got my daughter over here back in my mind probably. So shout out to all you guys for that one. So all right, now we need a SVI pointing back this way, right? To put these two interfaces. So 1033.1. Let's put an SVI over there, and then we're gonna put them two interfaces. I believe in that VLAN, right? If I'm not mistaken. Them two got to be in that same VLAN. Oh no, let's see. 1033.1 is the other SVI. 1033.1. So let's go to global config mode. 1033.1. Global config mode, and we're gonna call it interface VLAN 3 for this one. And then IP address is 10.33.1, 10.30.3.1, Sutton Master /24. If y'all is over there in my ear telling me, and I'm not even listening to y'all, I'm just like, what the fuck is wrong here, man? It's just like, why this shit ain't working, man? And y'all telling me, man, what the fuck is this? And I'm not even paying attention to y'all chat. But y'all, shout out to you guys for that one. Let's do a no shut for that. That ain't gonna come up because there ain't no ports in that VLAN. So let's go ahead and put, I believe we might have to put both of these ports in VLAN 3 for this to work, if I'm not mistaken, right? Let's show our work. Do show IP interface brief and exclude unassigned. We got interface VLAN 3 is down. So yeah, I believe we got to put those two in VLAN 3, right? If I'm not mistaken, I believe that's what you got to do though. Interface. Let's get out of this. Interface range. Yep, he does say that actually. Matter of fact, step 6 was assign appropriate VLAN to edge ports using the range command. So that's what we got to do. The edge ports are over here. These two are the edge ports. He said assign them into the correct VLAN, which will be in this case VLAN 3. Interface range. What is that? It was up here. 1 and 2. So, man, wrong device. FA 0/1-2. We're gonna say switch port access VLAN 3. Now we got the S3. We got that SVI up. Let's triple check y'all work and make sure that SVI has the correct address. Pipe exclude unassigned. We'll see it's 30.2 for the laptops gateway, right? 1032.1, and then them two right over there is 1033.1. All right, so that's fine. And then we got to turn up. Well, these interfaces are turned up. They're not turned up just yet because these two are down. So we need to put some IP addressing here, and then turn those up. And then the last step was to make Decor the primary spanning tree route for both of those VLANs, which is VLAN 2 and 3. So real quick, let's turn up those interfaces. Let's do the spanning tree part. I'm all over the damn place. Configure terminal. We're gonna say spanning tree VLAN 2. Let's do 2 first. Root primary, and that's how we do that. And we're gonna say spanning tree VLAN 3 root primary. So now he's gonna be the primary. He's gonna be the root switch for both of those VLANs, but it don't even matter because he'd only switching that in Daytona anyway. So we do a show spanning tree, and we could just do that, and then we'll see right there. He is the root for VLAN 2. We don't have VLAN 3 just yet because them interfaces are turned down. So that's why there's no spanning tree instance for it. Right? Yeah, that makes sense. See, we only have one spanning tree instance, and it's for VLAN 2. And he is the root. He's also the root for VLAN 3, but there's no instance for it just yet. So we gotta turn these interfaces up. They're already up, but they're not connected to anything because these are down. So let's go ahead and turn those up real quick. Enable. Let's do a show IP interface brief. I know my daughter's excited right now. She's just like, damn, it's Sunday night and I'm still. Oh, don't worry, I'm gonna put your ass to bed. Go to sleep. Interface GI. I'm probably gonna be 0001, 001. Let's do a IP. I'm sorry. Yeah, his IP address supposed to be. It's gonna be 1033.3. 1033.3. Y'all see that? IP address. Oops, I'm almost typing it again, man.
You stupid.
IP address 1030.3.3. Oops, 3.3. Sudden mask of. What's that? Slash. It's probably gonna be a /24. He didn't put the IP, the subnet mask there, but we're gonna give it a /24 subnet mask. In this case, 255.255.252. Come on, man. I forgot the address keyword there. Y'all hit that like button. Bad mask. Let's do a .0. That's what I meant to do. Let's do a no shut for that. Now this interface is turned up. So now we should theoretically have a spanning tree instance for at least VLAN 3. Let's do a show span again. Remember, we only had one instance. It was for VLAN 2. We do a show span. And there it is right there. And we are also the root for VLAN 3. So that's a good sign. Y'all hit that like button. What's the next thing we got to do? Let's turn up this side and give it an IP address. So let's go over here, 1033.2. 1033.2 enable, global config mode. What interface is that? Do show IP interface brief. And we'll see is most likely going to be that gig 001 interface. So interface gig 00/1 interface. And give him the IP address of, what is it? 1033.2 right there. See that? 10.30.3.2. Subnet mask of /24. 0. No shut. That interface turned up. So that's a good sign. What was the last step? I think that was pretty much it. He said assign the appropriate VLANs to the edge ports by using the range command, which we just demonstrated. He said make day core primary spanning tree route for both those VLANs, which we just did. We created an SVI for both the laptop and the edge network right over here, right? We created an edge SVI over here. We created an SVI over this side. This side is amber right now because the spanning tree is still loading up. I could fast forward if I want to, but I like to do things in real time. What else? This is the part where I wasn't sure about, and we might have to reconvene tomorrow for this part, but create mutual redistribution between Eigp and BGP. We did that on this side. We took those BGP routes, injected them into Eigrp. Now we needed to take these Eigp routes, inject them into BGP. That's called two-way redistribution, right? Remember, this guy's going to be translating, or he's going to be pretty much redistributing routes both ways. And I would have thought that these two guys would have seen that 10-100, this network that sit back here. But I don't see it just yet. So we may have to just reconvene tomorrow. Like I said, I need to put my daughter to bed. And y'all hit that like button. Hit me with that subscribe button if you're new to this channel and stuff like that. We typically stream every day, as you can see. This shirt right here says lab every day. And lately I've been doing that. Yesterday I did miss it, but I think I was on like a 3-week streak. Bars. Yeah, we're going to continue to try to do that. Even if I'm like out of town, I might be moving pretty soon. So we gonna make this work, man. Let me just before I let y'all go, man. I'm not gonna be able to sleep tonight. Let me just make sure show IP routes. It was supposed to be the 10. I got it in my cache there, don't I? Nope, I don't. Show IP 100.10.10.0 network. Yeah, see, that network is not back there. I would think he would have known about these networks back here, because he is redistributing them into Eigrp. What am I missing something here? Show IP. Let me make sure. Trey said catch it. Oh, okay. BGP don't need a metric. Okay, so I mean, I did that, didn't I? Let's just make sure. Let's just look real quick. Show IP. Let me show run real quick, and then we're gonna call it a night. Where is it? Where are those metrics I put in? I put in those metrics right over here. Right? I went into Eigrp and took those BGP routes and redistributed them. And it's BGP 100, so that is correct. Probably because... No, that's BGP 200, so no, that's not it. Yeah, I would have thought. Yeah, see? Because see, these guys ain't going to be able to ping back there. But let's see. He probably got those Eigrp routes though, right? Let's see. So, no, God! Control Shift 6. There you go, right here. Enable. Show IP routes. Eigrp. Let's take a look. He don't have no Eigrp routes. So that got to be it, right? That's probably the issue. He don't know about these Eigrp routes that are sitting back here. That's probably why. Let's see. He obviously got them. What am I missing here? Let me name this something else too. Well, I will do that in a second. Man. He said, "I appreciate the stream. See you tomorrow." Yeah, let's go ahead and kill it, and then we're gonna finish this tomorrow, man. For now, yeah, I'm gonna see if that's what it was. Craig, shout out to Craig for that one. But I think I gotta remove that part right there. I'm gonna fix it. And I'm gonna tell you how I fixed it. But I already did this whole complete lab. There's something I'm missing right there, man. But for now, comment, like, subscribe to the network.